All right, section 12.3 is very short. It's on arithmetic series. And we all know what arithmetic means. It means the numbers change consistently. But we're going to talk about two words, finite and infinite, because they go along with the word series. A finite series is any series that ends, or if you want to use the word terminates. You can find the sum of a finite series. You can't find the sum of an infinite series, because infinite, most of you know, that would be any series that goes on forever. You can't, obviously, since it doesn't end, you can't find the sum. Where does it end? Now, there's a very specific formula for finding the sum for an arithmetic series. So the sum of the first n terms, meaning it's finite, the sum of the first n terms of an arithmetic series is this. Capital S, which means the sum of the first n terms, is equal to n times the first term in the series plus the last term in the series, the whole thing divided by 2. Write that formula in your notes, put a highlighter around it, a box, whatever you got to do. Big formula. Let's do a couple of examples. Example number 1 says find S of 15. Well, that means find the sum of the first, sum of the first 15 terms of that pattern. 11, 3, negative 5, etc. Well, the first thing we got to do is we got to test, is it arithmetic? And if you look at it closely, it is, because the numbers are going down by 8. So, if I was to write this in summation form, it would be the sum from n equals 1, and it tells us the top number is 15. And since it's arithmetic, we need to write our formula, which would be negative 8n, because that's the slope. And our 0 term, which is out front here, following the pattern, would be plus 19. So that's what we are finding the sum of. Now, if I go back a slide, it's arithmetic and it terminates. Therefore, I can use this formula right there. So, the sum of the first 15 terms is going to be equal to n. Well, n is 15 times the first term in the pattern, which was 11, plus the 15th term in the pattern. Ooh, now we got to do a little bit of work. What we need to do is we need to take 15, because we got to find that term in the pattern. We need to stick it in there for n. So we're going to go negative 8 times 15, and then add 19 to it. And you get negative 101. So plus negative 101, the whole thing divided by 2. That equals 15. And in the parentheses, you get 11 minus 101, which is equal to negative 90. The whole thing divided by 2. And the final answer to that is you take 15 times negative 90 and you divide it by 2, you get negative 675, which would be the sum of the first 15 terms in the pattern, 11, 3, negative 5, negative 13, etc. The first 15 terms add up to that. Finally, example number 2. It says find the sum from n equals 1 to 12 of 4n plus 3. Well, again, in our formula, If we're going to evaluate this, and this is an arithmetic sequence or series because it's in the form y equals mx plus b, we need to find the first term in the pattern. So what I do is I take 1 and I stick it in for n. 4 times 1 is 4, plus 3 is 7. And then I find the last term in the pattern, which would be the 12th one. And so I stick 12 in for n. 12 times 4 is 48, plus 3 is 51. And now I have the information I need. So the sum of the first 12 terms in the pattern is the number 12 for n, and in parentheses we add the first and the last terms together, and we divide it by 2. 7 plus 51 would be 58, and we're going to times that by 12 and divide it by 2. And I believe you get an answer of 348. And that is the sum of this finite arithmetic series from 1 to 12 of 4n plus 3. And that's basically section 12, everybody. I'm going to go back. Section 12.3. Section 12.3 is the sum of a finite arithmetic series, and there is your formula.